All right, watch this. People often use centrifugal force to describe what's happening to this ball. It's being pushed as far away from the pole as possible, right?
No. Actually, the only force being exerted on the ball is pulling it toward the center of rotation as a result of what's called centripetal, or center-seeking force. Now I know what you're thinking. You're thinking, Hank, there has to be a force. Because if you cut the string, the ball's gonna fly straight away from the pole, right? Nope. You just have to understand what centrifugal and centripetal force really are. First, centrifugal force is what's called a fictitious force. From the frame of reference of the ball on the string, it might feel like it's being pulled away from the axis of rotation.
But there's nothing actually acting on the ball to pull it outward. All the ball wants to do is move in a straight line. That's not centrifugal force, that's just inertia.
Now, as with most things in classical physics, it was first described by Isaac Newton, inertia, his first law of motion, which says that a moving body will continue to move at the same speed in a straight line unless a force acts upon the body.
And in the case of the tether ball, the real force that's acting on it, the force that's keeping it from going in a straight line, is centripetal force.
You'll notice here I said real force. Real forces require physical interaction between objects. So in this case, the string is interacting with the ball to create centripetal force. This force keeps it moving along a circular path, and the force is directed toward the center of that curved path.
Every instant the ball is flying around the pole, the string can only do one thing, which is hold the ball at a fixed distance from the pole. In other words, the string is exerting a real force on the ball, pulling it toward the ball, and this is what keeps the ball from going in a straight line. If I cut this string, which I'm not going to do because that would be mean to all the children, but if I did, the ball wouldn't fly straight out away from the pole. The ball would continue going in a straight line, a 90-degree angle from the pole, because that's what the ball wants to do. The ball wants to go straight.
The centripetal force of the rope constantly works against inertia by keeping the ball from traveling in a straight line, and that constant fight against inertia is what makes the ball feel as if it's being pulled away from the center of rotation.